The goal of this demo is to show how the application can be used to conduct a comparative analysis. For this demo, we will compare radiomics complexity levels to determine the optimal one. You can download the feature sets available in our documentation to test this yourself. Let's get started. You can see that we have 3 distinct pipelines. Each pipeline represents a unique radiomics complexity level. The first machine learning pipeline focuses solely on morphological features, while the second incorporates intensity-based features. Finally, the last pipeline utilizes texture features. All feature sets are cleaned, normalized, reduced and trained the same, therefore only design and data nodes are different. We also use the same analyze node to compare all pipelines through a metric heat map and feature importance histograms. Let's hit run and come back once the results are available. First, the results are systematically organized by pipelines. As expected, 3 pipelines were identified. In each pipeline, we can see the results for the experiment. For instance, in the first pipeline, we can see the morphological features experiment metrics for each set, training, testing, and in some cases the holdout set. Other analysis plots like the feature importance histogram are also accessible here. Same goes for other pipelines. Moreover, for a better comparison, we can activate the compare mode where you can compare the metrics from each pipeline for the holdout, test, and train sets. In our demo, the intensity features achieve the highest mean AUC in the testing set. In the section below, you can find other comparison plots generated by the Analyze node, mainly a metric heat map with p-values assessing statistical significance. The heat map here confirms the statistical significance of the intensity features-based model with a p-value lower than 0.05. Lastly, don't forget that you can generate a Python code in a notebook format by clicking on the Generate button. Note that this is applicable to other analytical comparisons, like machine learning algorithms or feature selection methods comparisons. Thank you for joining us in this tutorial.